Hi. Now, in today's lecture, we would be going through space-time and space velocity, right? And it's essential to go through these small terms which would be used in future lectures, right? So, space-time and space velocity. What are these basically, right? Like we have studied in previous lectures that the time is the performance measure for batch reactors, right? What that means is, if you remember, we said that longer the time the reactants spend in the batch reactor, the more would be their conversion, right? So conversion was maximum in batch reactors. Why? Because the reactants can spend more time in batch reactors, because we can leave reactants in the batch reactor for a longer period of time, right? So here the performance measure for batch reactors is time. Longer the time, longer is their performance, right? Similarly, now if we talk about flow reactors, batch reactor, right? For batch reactors, I can write it now here. For batch reactors, time is the performance measure. Time is the performance measure, right? Longer the time reactants spent in the batch reactor, more would be the conversion, right? Similarly, for flow reactors, right? For batch reactors, time is the performance measure. What about flow reactors? Flow reactors, if you remember, this is the kind of, suppose this is your PFR, right? We are feeding this reactor from one end, right? And these and the feed, right, which is basically the reactants, they will travel the entire volume of this reactor and they will come from the other end, right? And at the time when the reaction is occurring, right, inside this reactor, there is continuous movement, right, continuous flow of reactants from one end, and the reactants are coming out from the other end, right? So this flow is continuous. That is why we call these as flow reactors, because this flow is continue at the time of reaction happening inside the reactor, right? From one end we are sending the reactants, from the other end the products are coming out, right? But this was not so with batch reactor. In the batch reactor there was no inlet and outlet, right? We can just leave the reactants inside this tank which is closed. It has no inflow and outflow like this, right? So here, longer the time these reactants spend in the reactor, more would be their conversion. Now for flow reactors, this space time and space velocity are performance measures, right? Space time and space velocity. So these are performance measure flow for flow reactors. This is basically the kind of definition, right? What do we do with this space time and space velocity? We measure the performance of flow reactors, right? Now what is this space time? Space, you can understand the space inside the reactor. Here the space refers to the space inside the reactor, right? And time, you know what is time, right? So when you send a feed from one end, right, the time this reactor takes to process one feed is your space time, right? So using space time, or the time taken by this reactor to process one feed, right, using this you can measure the performance of the reactor. Maybe the less time this reactor takes to process the feed, more is its efficiency, right? That way. Now, so this is your time taken to process one reactor feed, let's say one volume reactor feed, right? So if I say 2 minute, space time is 2 minutes. This means that the reactor takes 2 minutes to process one volume of reactor feed, right? Now second is your space velocity. Space velocity is how fast these reactants are moving in the reactor, kind of, right? So the number of space velocity is the number of feeds, the number of reactor volume feeds that this reactor can process in unit time, say in 1 hour. That is your space velocity, right? So if I say that space velocity is 5 per hour, right? Space velocity, let me write it like this, it's 5 per hour. That means space velocity is 5 per hour. That means it means 5 volume reactor feeds can be processed in 1 hour, right? So these are space velocity is the number of feeds, right? Space velocity is the number of reactor volume feeds, right? Or it's the number of feeds, right, that this reactor can process in 1 hour, right? Or maybe 1 hour, 1 minute, right? Likewise, the way you are calculating it. So how can this be the performance measure? If it can process more volume or more feeds, right, in 1 hour, that means its performance is high. That way you can measure it, right? So how to define it? The space velocity, number of reactor volumes, right, of feed at which can be treated in unit time, right? So this is number of reactor volume of feeds that can be processed in unit time, right, is your space velocity. So these are two performance measures: space time, right, how much time does this reactor take to process one feed, right, how much time does it take for this reactor to process one volume of feed, right, and how many volume of feeds can be processed in 1 hour. These are two factors, right? So this is it. So the performance of flow reactors can be measured in terms of space time, right? Space time, that is the time taken to process one feed, and the space velocity, that is the number of feeds that can be processed in 1 hour or in unit time, right? So this is it. These are two parameters using which you can measure the performance of your flow reactors, right? And for for batch reactors, time is the performance measure, right? So I hope this is clear. Thanks.